Hello and welcome to your very own Blockchain 101 for beginners. Now in this video, we really have two goals and you could have one of the two. Number one, we want to explain what the blockchain is and how it functions for an absolute beginner. That means if you know absolutely nothing about the cryptocurrency space, at the end of this video, between our simple and a little bit more in-depth explanations, you'll be able to go from knowing absolutely nothing to being able to adequately explain these things to someone else. That means after this video, you should be able to have a general idea of what the blockchain is, how it works, and then be able to interpret that information to someone else, whether it be friend or family, who also knows nothing about the blockchain. Number two, if you are someone that knows about the blockchain but doesn't really know the intricate workings, perhaps you want to start coding on the blockchain with really any language that you prefer, this will also accomplish that. You'll come out of this video with a better understanding of really everything under the hood and what's going on when, say, someone mines a block on the blockchain, or what is really happening when you submit a transaction. Also, how is this information being stored, and how is this immutable or unchangeable based on what we call a consensus? Well, we are going to start with a very simple form of showing you what exactly a block is. You might notice that I have this little box right here. Now, this little box is going to represent a block, and this block is going to have three parts. Now, for example, let's use Bitcoin. While the algorithms behind cryptocurrency were thought of back in 1991, it wasn't until Satoshi Nakamoto in 2009 put these into use. Now, originally, the blockchain was thought of as a sort of ledger, or a ledger for storing information, or in Bitcoin's case, a ledger for storing transaction information. So what we have here is three main parts. We have an input, we have an output on the bottom here, and we have our main block. So what we're going to do is, in this main block, we are going to be storing information. Now, of course, the blockchain is made up of a multitude of blocks, but let's break it down to the single block level. So in this block, we are going to be storing transactions or transaction information, and we're just going to call that data. So in this block, we are storing data. Now, this would be the first block, or the genesis block, in our blockchain, which means our input isn't really going to have anything, as this is where it starts. So up here, we're just going to have pretty much a long string of zeros. There is no input. This is our genesis block. Now, once the data in here is inputted, that's where our miners come in. If we want to submit this data to the blockchain, that block will need to be mined. Now, once that block is mined, we will then have an output which we can send to our next block. So, of course, it's going to be a lot longer than this, but let's just say our output here is number 1. So coming in, we have a block. Of course, our input to this block is nothing, as this is our genesis block. We have our initial data stored on this block, and then once that is mined, we have our output, which is sent to our next block. So this is really just the simplest form of explaining what a block in the blockchain is. But let's go a little bit more in depth. Let's actually go a lot more in depth, but still in simple, easy to understand, and really easy to digest information. Now, I hope you are seriously ready to get into some awesome things and info about the blockchain. But real quick, I do have to thank today's sponsor. Not someone that's trying to sell you something, something, but someone that's trying to save you something. Fight NFT Fraud by Tovera is an amazing new website and Chrome extension that makes sure you do not get scammed when buying NFTs. Whether you are an NFT investor, making sure that you are buying an original NFT and not a copy, or you're a developer that wants to make sure that nobody has access to your artwork and nobody is trying to use it, Fight NFT Fraud is bringing a new era to the NFT space and the NFT community, ensuring that none of us ever again have to face an NFT scam. They're doing all of that, and they're doing it for free. So down in the description and the pinned comment, you can check out Fight NFT Fraud and their organization for yourself. Now let's get into some seriously cool stuff. So before we jump right into the block, at least in this format of explanation, we need to look at a hash. What exactly is a hash? Well, a hash is just a format of storing that information and generating an output. So real quick, if I type in, say, my first name, Andrew, we will see down here that it produces a hash. Now anything else we add to this will continuously change that hash. Now of course the hash for Andrew will remain the same, starting with C108. If I delete it and retype it, of course it will be the same. So this is basically how the hash recognizes and stores your information, so it can then be read and processed inside the machine and sent to another block where it can then take that input, store more information, create another output, so on and so forth, but we're going to get to that in just a minute. Let's actually take a look at a block. So we're going to go up here to our nice blockchain demo and click block. So just as we have here, we have a block that you can see. Now this of course is block number 1. We have our data spot, and then we have our hash, but you'll notice there's a couple of new things, and I'm sure you can spot what those are. Number 1, we have something called a nonce, and we will get into that in just a moment. Number 2, we have this new button down here called mine. Now mine is basically, think of it as a save button. And when we come to nonce, just for now, face value, we can think of this as attempts. Okay, we could say this is attempt number 72,608. This is basically what we plug into the data in the block to mine it. And of course we will get into that in just a minute. So we are on block number 1. So if you think of a blockchain, this is our Genesis block. This is where we begin. Now let's just say we want to store something, say Bitcoin, for example. So let's say John, and let's say sends, let's say 2 Bitcoin to Mike. Easy enough, okay? John sends 2 Bitcoin to Mike, and that is the information that we are storing on our first block. Now you'll notice that we kicked out a hash, but without getting too heavily into details, in order for this hash to be passed block to block, it needs to start with 4 zeros. So that would be representing or representative of a complete mined block on the blockchain. So this is what we're going to do. Now this mine is going to be almost similar to when you submit a transaction. Say you're buying an NFT. When you buy an NFT, it is processed in a block that is mined. Now until that block is mined, that transaction will be pending. So you can think of it as when you submit a transaction, someone somewhere out there is mining that block or processing that transaction. So if we go ahead and click mine, it will take this information and it will spit back a hash that starts with 4 zeros. Now you'll notice one thing. You'll notice that the nonce has changed. Well, what exactly is that? Well, in order to get this hash down here, a processor or a computer, a miner in the background, is going to be going through an extensive amount of algorithms trying to find an attempt or a number that coincides with the information in the block to spit out a readable or processable hash. So what if we go up here and we actually manipulate the nonce one by one? Let's clear this out. So we have our information right in here. The information we want to store on this block is that John is sending 2 Bitcoin to Mike. Okay, well now we want to actually store this on the blockchain. So what we're going to do, because you'll notice our hash down here is not readable, it's not processable, because we need the 4 zeros to be in the front. So we're going to go in and manually, let's try nonce 1. Well, nonce 1 doesn't do it for us. Let's try nonce 2. No. Nonce 3. No, we still don't have any zeros in the front. Say we can go up to 50, and that doesn't work. We can go to 500, 5,000. Now what the computer is doing in the background when we click mine is it is instantly going through thousands of these nonces, or thousands of these attempts rather, to find what number can we plug in here that with this information we handed it will produce a readable block. So what a miner is doing in the background essentially is running continuous algorithms matching this information, and it's doing the same thing we did. It's going 1, no, 2, no, 3, no, 10,000, no, 11,000, no, and it's coming back to that nonce, what was it, 13,558. When it reaches this number, it is the first time we have a readable hash that we can pass to another block. Therein, we now have one complete block. We have block number 1. We have a nonce that makes this readable in machine format or computer format on the blockchain. We have our information stored, and you'll notice that the block turned green, which means, essentially think of it, when it's red, it is just a pending transaction or one that has not yet been put through, and when it becomes green, it is now a solidified block. Now the blockchain is ready to go on to block number 2, 3, 4, and so on to continue processing and storing more information. Again, in the case of Bitcoin, it is transaction data. Now let's go ahead and take this one step further, because of course a blockchain is a chain of blocks and not just one single block. So how do we take this one single block and get a better visual of what the blockchain looks like? Well, in this demo program here, we go up to blockchain, and now we can kind of see the blockchain in front of us. We have 5 blocks. We have our Genesis block. We have a nonce that doesn't mean anything yet because we have not inputted any information, and we have one extra thing. We have this previous hash. Now this is how, when people say the blockchain is immutable or unchangeable, it is because, and we'll get into this even further in a minute, if this previous hash does not match the next block, well, then the blockchain will spit out an error. It will say something was changed, something is wrong, and it will kick it back out at you, and whoever runs the blockchain, whether that be, unfortunately in some cases, a centralized organization, or in many cases a general consensus of everyone in the pool. So let's go ahead and do this really quick. Let's go ahead in block number 1. Remember, John sends 2 Bitcoin to Mike. Okay, that is what happens in block number 1, and we will go ahead and click mine. Now you'll see this block is now complete, and we can move on to block number 2. You'll also notice one more thing. The hash that block number 1 spits out is going to be the same exact hash that is now the input. Remember, if we go back in here, we have our data, we have our input, and we have our output. So when we take block number 1 and we go over to block number 2, the output of block number 1 must now match the input of block number 2. So that is exactly what we see happening here. We go over to block number 2, and we see our previous hash is the hash output from block number 1. So let's go ahead and say Mike then sends one of those Bitcoin to Jack. Okay, so now we have John sent 2 Bitcoin to Mike. Mike then sends 1 Bitcoin to Jack, and we'll go ahead and mine that. We will then get a nonce for this here, which makes this readable. Once again, the hash that is our output from block 2 becomes the hash that is now our input for block number 3, and this just goes forward and forward. Now to save time, let's just go 1 here. Okay, we'll go ahead and mine that real quick. We'll go 2 here, and on our final block we will say 3. Okay, so now this is a complete blockchain of 5 blocks. Granted, the information that is stored within is very simplistic, as it's not actually transactions, but you can envision when this is running, say on the Bitcoin blockchain, each little block is its own transaction and large string of basically, hey, this is what happened at this time on this block, here is the hash for that happening. So now we mentioned that the blockchain is unchangeable and immutable, but how exactly does that happen? Well, let's say that someone wants to go back to block number 2, and all of a sudden they want to change something. So they receive their 1 Bitcoin, but maybe they want to say, hey, you only sent me half of a Bitcoin. Okay, so we're going to go back, we're going to change this, and we're going to mine it. So now Mike has only sent half of a Bitcoin. But what has happened? You'll notice that the blocks on the right are now red. Now, why did that happen? Well, if you read down at the hash, we have a breakpoint, which means in block 3, we now have a previous hash that is not being spit out, or it is a different hash, right? Because with this, right, when he sent 1 Bitcoin, like it originally was, look at that, we've changed it back and everything is now green and the blockchain can proceed. But if anything changes, if any individual, any group, or anything in general impacts a previous block, every block beyond that point will become invalidated because senses something has changed, something is wrong. One of my favorite examples of this is back when McDonald's had their Monopoly game. Well, it was a centralized service, which means when one individual ran off with a bunch of winning pieces, there was no way to verify that those pieces were in fact no longer in circulation. However, if that same thing had been ran on the blockchain and all of a sudden one individual changed an element of that game, like say they took some winning pieces from that pool, well, then everyone would be alerted. The entire blockchain would essentially shut down for that moment until everything was put back correctly. So that is one way that you can see that nobody can change something on the blockchain without everybody all of a sudden knowing that that was changed, and number 2, that information being completely public. And remember, those previous blocks would be stored, so everyone would know what has changed, they'll know when it changed, and they'll actually be able to go in and see the differences between what that old block was and what that new block has become. Now, there's some more advanced things like an actual signature on that block, which allows people to see what wallet or whose wallet actually interacted with that block and actually manipulated the information inside of that block. And that is why the blockchain is essentially, it is unchangeable and it can't be messed with, because if it is, everybody will know, everything will be put at a halt until it has gone back to the way it should be. Alright, now we talked about this consensus. This consensus is what keeps the blockchain legitimate. So let's go ahead and go in here and let's say data 1, data 2, data 3. Now we can go ahead and mine that, and let's go ahead and mine that. Now what you see here, you see peer A, peer B, and peer C. You can kind of think of these as participants on the blockchain. All of these miners are coming together to process transactions, and they all basically have this static ledger of the history of the blockchain, where we are in the blockchain, and the individual hashes that are being spat out. But let's go ahead, for argument purpose sake, and say, well, peer A tries to change the blockchain. So let's go ahead and say maybe peer A comes in, and on block number 2 they sneakily throw in a 4 instead of the 2, and they go ahead and mine that and submit it, and they say, okay, well, this is what it is now. Well, what we're going to notice is this consensus comes in. So we'll notice that this new hash has been spit out by block number 2. But what we can notice is the consensus, so we need 51% to be a consensus. In this case, it will be 2 out of 3. Peer B and peer C still have this original hash output for block number 2. You can see it starts 12FA. Okay, well, that checks out. Let's go to the next peer, 12FA. Okay, well, that checks out. Let's go back to the original peer. DD12. That's different. That means that peer A is now invalid, because the consensus says that if we look at this blockchain, we go to block number 2 and we read the data, well, we can see that 2 out of 3 are saying that the output hash is 12FA. Well, we can see that on peer A, the output hash is DD12. Well, that's kind of strange. That means that whoever or whatever is operating inside of peer A, they're doing something a little bit different. They are changing or trying to manipulate whatever information happened inside of block 2. So that is essentially what happens, but across tens of thousands of different peers, you have a basic consensus that ensures that the blockchain stays legitimate. So finally, in this simple instruction, let's take a look at what it would really look like if we took everything we just learned and put it into a real transaction format. Well, here we basically have a Coinbase transaction demo. Now we can see, okay, $100 was sent to Anders from the Coinbase wallet, and let's just say Anders bought $100 worth of Bitcoin. Okay, well, Coinbase says, well, we took $100 from our wallet and we sent it to Anders. Okay, well, let's say now Anders wants to take that money and send it to Sophia, Lucas, Emily, and Madison. Say he's going to split that up and send it out. Okay, well, like before, we have the output hash for this transaction in block 2, which is then sent over to block 3 as the input. But, as we know, what would happen if we say, well, all of a sudden we're going to go back and say, instead of sending $20 to Lucas, Anders, let's say he sent $19, and we're going to mine that. So the first thing we see is every transaction past this is now invalidated because we changed something on block 2. So that would really be step 1 for searching for what happened. Well, we'd go back to the initial block where something changed. In this case, it would be the block to the left of our invalidated block to say, well, what exactly changed? Well, we see the information that is now here, but it may be a little difficult to know what changed. Therefore, we have our peer system or our consensus. We can go down to, say, peer B, and if we compare what we have from peer A with peer B, we can very quickly see that peer A sees $19 being sent from Anders to Lucas, whereas in peer B sees that original $20. Well, that's a 50-50, so how do we know who is correct? How do we know which peer has the legitimate and most up-to-date information? Well, we check peer C. So we go down to peer C, and we compare block number 2, and right away we can see block number 2 on peer B and peer C are the same, which means we have a 2/3 consensus, which means we can invalidate any information in peer A. Peer A is now invalid, something was manipulated, something was changed, and the consensus says whatever is happening in here is incorrect. Therefore, we hop down to peer B and peer C, and that is how we can find the legitimate information on the blockchain. Now, granted, in the real world or in a real world application, there's many more than just 3 peers. Many more. But for this example, it works just fine. Now, if you have any questions, I know we went over this somewhat fast. It is a lot to wrap your head around, but we wanted to just get the basics in a very simplified version that you could then go and explain to a friend. So let's go ahead and recap what we've learned. A hash is basically just an easy way for the computer, or in this case the blockchain, to store information. You put something into data and it spits out a hash. Now when it comes to a block, they're going to do essentially the same thing, except it has to be able to be interpreted into Web3 technology or blockchain technology. Meaning if we put in the same information, we must have an intermediary or someone to process that transaction. We have to have what we know today in layman's term as a miner. Once we mine that, it will go through all of these different attempts and all of these different numbers almost instantaneously until we can accurately store our information in a way that can be interpreted and understood by the following block. These following blocks are in a chain. Now, this chain is going to take the output from the previous block and input it into the next block, going down and down and down as the chain continues to grow and grow and grow. Now, we know from the peer system, or our system of consensus, that if anyone was to try and manipulate the information, transaction ID, or anything that was stored in one of these blocks, it would quickly invalidate everything that happens after that block. We also know, because we have this system of consensus and all of these peers processing all of these hashes at the same time and storing information forever, that we only need 51% consensus to know or be able to determine the legitimate from the illegitimate information on the blockchain. Now, we know that we can take this in many different ways. In the case of Bitcoin, we are storing transaction data. In the case of, say, Ethereum, maybe we're storing something else, like smart contracts that can talk with one another. Maybe smart contracts that deploy, say, an NFT collection. When you deploy a smart contract, you're going to go through essentially the same thing. You're going to store that smart contract on a block. When you process or actually do push that smart contract out into the Ethereum mainnet, somebody is going to have to mine, or rather find a nonce that allows that smart contract to be readable and actually interacted with on the blockchain, which means anytime you mint an NFT or buy an NFT or send ether between people, say you want to send half of an ETH to a friend, you are initiating this process that we just learned about. You're storing information on the blockchain in which a miner is coming in and transacting that, and the blockchain continues to grow. Now, if you have any specific questions on what we went through here today, definitely let me know down in the comments below. If you learned something new, hit the like button, and if maybe you just had a little bit of fun, make sure you subscribe and hit that notification bell. That way you're at the forefront, you're at the most recent block whenever we release new content. As always, stay profitable and keep hustling.